Hello everyone and welcome to 30 Days of Java. It's day 27 now and today we'll discuss unit testing in Java. In this video, we'll understand what is a unit test case, why do we need it, and how to create one. So let's get started. Let's understand why do we need unit test cases through a real world example. Imagine, through hard work you have finally reached the finale of MasterChef Cat and created the perfect dish, but your opponent, Mr. Evil Cat, has a plan up his paws. While you were busy preparing the side dish, he added some sugar in your main dish without you noticing. This could cost you the championship, but you have a checklist of tests that you always do before serving out the food, which includes tests like smell the dish, check if the dish is still hot, check its presentation, and taste the dish. The final test fails and you knew that something is wrong, so you quickly add some spices and herbs to even out the flavors and become the first MasterChef Cat. Similarly in Java, unit testing is the process of testing individual units or components of a Java application to verify that each unit functions as expected. A unit in Java typically refers to a single method or a small group of methods within a class. The primary goal of unit testing is to ensure that each part of software performs correctly in isolation before integrating it with other parts of the application. Now that we understand what and why of unit testing, let's understand how do we write these test cases in IntelliJ. Now let's start by creating a new project in IntelliJ. So we'll click on New Project and we'll name this project as Unit Testing Example. For the build system, we'll use Maven this time. So Maven allows us to easily add and remove dependencies into our project. By using Maven as a build system, you get a new file called pom.xml. This file can be used to add third-party dependencies into your project. For adding the JUnitFramework, we can get its details from Maven repository. So if you go to this link, mavenrepository.com, and then search for JUnit. So for this example, we'll use JUnit Jupyter and we'll use the version 5.10.2. We can copy this code and then type dependencies, and inside the dependencies, we'll enter the value that we just copied. Now by default, you might be getting a compile time error where the version number would be presented in red color. To resolve that issue, simply go to Maven and then click on Reload. This would reload all the Maven dependencies. And as you can see in the dependencies, it just loaded up all the Jupyter dependencies. We can close this. Now we'll write a unit here, that is a method on which we'll be writing the unit test cases. For that, we'll go to Java, then create a new class called calculator class. Inside this class, we'll have a method public int calculator. Now to save our time, I'll simply skip this video and write a basic implementation of a calculator. Now here, I have written the logic for a simple calculator application, which takes in 3 arguments, 2 integers that will work as the operand a and b, and the operator. If the operator is positive, we'll add those operands. If it is negative, then subtraction. If it's asterisk, then multiplication. If it is /, then division. And if it is modulo, then remainder. And if it's nothing from the above ones, then we'll throw an illegal argument exception saying invalid operator found. Now to generate a unit test case file, I can press Ctrl+Shift+T, and then it gives me an option of creating new test. So I'll keep its name as calculator class test and then click on OK. Now as you can see, it created this file under test and Java folder. Now here, to define a unit test case, I need to add in an annotation @test. Now this annotation would denote that the method we'll be writing is a unit test case. So for unit test case, you generally do not require any return type, so I can keep it as void. Then I'll pass its name as calculator underscore, and then the name of the operation, that is add. Now inside this method, I'll create an object of calculator class where bj, and then we'll use a method from JUnit package called assert equals. Now this method can be used to check if the expected result is equal to the result returned by the method. So for expected value, I'll pass in 4 and then obj.calculator, and I'll call this method with 2 and 2 as operands and the operator as positive. And that's it. We have just written our first unit test case. Now this unit test case is checking the calculator method with operands 2 and 2 and performing an addition operation on them. If the result is 4, then this unit test case would pass. So now let's run this unit test case. And as you can see, this green tick denotes that the unit test case passed. Now if I change the expected value to something else like 5 and then again run this unit test case, you can see it fails now. And it also gives you the reason, that is, it was expecting the value 5 but then it got the value 4. Now let's change this back to 4. Now there are different variations of assert method that we can use. So if I type in assert, you can see other than assert equal, I also get methods like assert true that can be used to check if a boolean expression is evaluated to true or not. So we can write the above statement, that is object calculator pass it here and then equal to 4, and this would work the same. Other than that, we also have assert array equals that can be used to check if both the arrays are equal to each other or not. And then we also have methods like assert not equals that can be used to check if both values are not equal to each other. That is the complete opposite of assert equals. Now let's remove this. So we have already created a unit test case for the addition part of calculator method. Now let's write other unit test cases for different operations. Now I can run all of these unit test cases by simply clicking on the class declaration here and then click on run. As you can see that I am getting 4 unit test cases were passed, but one of them was failed. Now let's look at this a little bit closely. As you can see here that I passed the value 1 as expected, which should be 0. Now again if I run this, and it works without any issues. Now there is another mode of execution here that can be used to check the coverage of these unit test cases. So if I click on any of the unit test case and then run calculator add with coverage, you can see that how many lines of code this unit test case is hitting. So right now it's hitting 25% of the lines, that is 3 out of 12 lines. And if I run all of those with coverage, you can see that I'm hitting 91% of the coverage. If I go back to my calculator class, we can see here that there is a green line here, which shows the coverage of the code that is being tested by the unit test cases. And the red line denotes the part of the code that is not being covered by the unit test cases. So I can create another unit test case in my unit test case file to cover this as well. If I go back, so if I copy this again, and I'll change this name as calculator underscore throws exception. Now for checking the exception scenario, we have to write this assert method in a different way. I can write assert throws. So the first parameter would be the name of the exception class that the code would be throwing. So it would be throwing illegal argument exception dot class, and then we need to pass in a lambda expression here. Inside this lambda expression, I can call obj calculator and then pass in 1, 2, and then as operator I'll pass in a. Now I can remove this part, and if I run all of those unit test cases again, you can see I'm getting the code coverage of 100%. That is, all of my unit test cases are hitting every line of my method. Now that we understand how to write unit test cases, let's see how they are advantageous to us. Suppose if you're a programmer who have just written this calculator method, and then down the line, another programmer works on this calculator method and makes a mistake of using negative here instead of plus. Now if there were no unit test cases here, then this problem would not get found until the code hits production. But since we already have all the unit test cases here, we can simply run all of those unit test cases before checking in the code, and it would show us that we are getting a failure back in our unit test case for addition. So I can go back and make the changes here, and then it would run without any issues. Now for most of the companies, they also use these unit test cases in the build pipeline to test out all the methods individually before publishing them on staging or production. Now before ending this video, I would also like to point out that while writing the unit test cases, you also need to be careful about the edge cases. Suppose here if I change this positive into asterisk, that denotes a multiplication, and then run all of those unit test cases again, you can see that all of those unit test cases are passing, even though when we are using the multiplication instead of addition. So this is happening because in our addition unit test case, we have given it the parameters 2 and 2. So 2 plus 2 equals to 4, and 2 multiplied by 2 is also equal to 4. So you need to be mindful and careful about these edge cases that your code can experience. Now to resolve this issue, I can simply make changes in this method and change its value to 8 and its operand to 4 and 4. And now if I run this program, you can see I'm failing at this unit test case. So let's change this back to plus and then again run this. So this is how you need to keep track of the edge cases that your code might encounter. As always, we'll end this video with a quote that says, "Make the best use of what is in your power and take the rest as it happens." Thank you for watching and have a great day.